Okay. So, I will the two lectures I have given on spectral estimation, which will be the content of this week 12, week 12. And now right now I am discussing about that what kind of problem you will face in that exam, and for the and what kind of question patterns will be there. So, those things I am discussing right now. Okay. So, as you expect that signal processing is lot of mathematics kind of things are there. So, you can expect that all that questions will be related to numeric. So, there will be a 3 section, section A, section B and section C. So, section A contain 20 short questions, 10 short questions carry 2 marks. So, 20 marks. Section B contain 10 short questions carry 2 marks, that is 20 marks. So, 40 marks, and then section C contain 20 questions, which every question is 3 marks, and that contains 60 marks. So, total 100 marks. Section A 20 marks, section B 20 marks, section C 60 marks, 3 into 20. So, 3 marks each questions, and there will be 20 questions. Section A and section B required very low computation, maybe 1 line or 2 line computation, but section C required a computation. So, you may require, you have to compute, or you have to do that problem in pen and paper, and then you have to find out the answer, and then you have to give that correct answer. Although it is a multiple choice question, but we have to calculate that things. I can guarantee you 90% cases the question is numerical. Only few questions are there where some basic importance theory are tested, but that theory also I am not asking any formula. So, question does not say you that derive this formula or what will be the formula for this, no. Many times I have included the formula inside the question paper itself. So, formula is given in the question paper itself, but you have to fit the numerical things in that question, in that formula, and then you have to solve it, and then you have to compute that. For example, let us say, see that question number 1. So, determine the circular convolution of the sequence of x1 and x2n, where I can say x1n is given, x2n is given, and the formula is given. So, how do you compute? As you know that I can using and circular things. So, you know the forward, when I say x1n, so this is 0, so this is 1, 2, 0, 1, and when I say x2n, this is nothing but a 4, 0, 2, 2. Now, when I say, let us say I want to draw the sample value for x2 minus n. So, it is reverse. So, I can say if it is anti-clockwise, then it will be clockwise. So, if it is clockwise, then there will be 4, 0, 2, 2. Then what do you know that if I say what is x3m, so x3 0 is nothing but a n equal to 0 to n minus 1, x1 0 multiply by x2, x1 n multiply by x2 minus n, m equal to 0. So, if you see that what is x1 n? This one. What is x2 minus n? This one. So, I have to take the product and make that addition. So, I can say 4 multiplied by the 1. So, product is 4, 2 multiplied by the 2, 4, 0 multiplied by the 2, 0, then it is 1, 2, 0, there is 1, here is 1. So, 1 multiplied by 0, 0. Then what is the sum? It is nothing but a 4 plus 4 is equal to 8. Now, when I say x3 1, then x3 1 is nothing but x1 n plus multiply by, So, x3n, when I say x3n, x31, it is nothing but a n equal to 0 to n minus 1, x1n multiplied by x2 1 minus n. So, 1 minus means shifting by one sample. Which is shifting? Which will be rotated by one sample? This x of minus n rotated anti-clockwise by one sample. So, I can say if it is rotated, then that 4 will come to here, this 2 will come to here, this 2 will come to here, this 0 will come to here. Then it is product. So, 0 multiplied by 1. So, what is the product sequence? 0 multiplied by the 1, 0. 4 multiplied by the 2, 8. 2 multiplied by the 0, 0. 2 multiplied by the 1, 2. So, it is nothing but a 8 plus 2, 10. So, you have to compute it, then you have to choose the correct option. So, in the question paper, you have to compute it and then choose the correct option. Okay. Similarly, this question. Let us say this question. I will come to the next page, because so that question and answer can be seen in whole question and whole answer can be seen. So, let us say I said determine the value of x0, h1, h2, h3 for a linear phase FIR filter m equal to 4, which is a symmetric unit impulse response, frequency response is given, formula is given. So, this formula is given, all formula is given. So, m is equal to 4, that means m is even. So, u is equal to n by 2 minus 1. So, 4 by 2 minus 1, 2 minus 1 is equal to 2. Sorry, 2 minus 1. Now, how do I calculate H0? H0 is nothing but so first you say that what is G0? Let us say what is G0 is equal to minus 1 to the power k means 0 into HR 2 pi k is 0 by n. So, it is nothing but a 1 into HR0. So, what is the value of HR0? Is nothing but a 2. So, 1 into 2 is equal to 2. Then what is G1? Is nothing but a minus 1 to the power 1. Then HR 2 pi. So, k equal to 2, k equal to 1. So, HR1. So, HR1 is nothing but a minus 1. So, I can say it is nothing but a minus 1 into minus 1, 1. Now, if you see, if I want to calculate H0, so what is the value of H0? So, H0 is equal to 1 by n equal to 4, G0 plus 2 into k equal to 0 to 1, Gk cos 2 pi k by n into n equal to 0. So, I can say into half. Now, if you see k equal to 0 to 1. So, k equal to 0 means there will be two part will be there. So, one part will be 1 by 4 G0 into plus 2 into k equal to 0, G0 plus G0 cos k equal to 0 means cos 0 1 1 plus k equal to 1. So, G1 into cos 2 pi into 1 into half divided by 4. So, it is pi by 4. So, I can say it is nothing but a 1 by 4. What is the value of G0? Is G0 value, what is the G0 value? G0 value is 2. So, I can say 2 plus 2 into 2 plus G1 is 1, 1 into cos pi by 4. So, I can calculate the value. So, you have to compute the value and then give that answer. So, that is very much required. You have to compute the value and then you have to give the answer. So, all that question in section C are numerical which is related to the value. Let us say next question. Next question is determine, convert the filter system function equation to using digital IIR filter by means of impulse invariance methods, where the sampling frequency is 10 kilohertz. So, what I have to do? First, I have to calculate the pole of the system. What is the pole value? S square minus 4s plus 5 is equal to 0. S square minus 2 into s into 2 plus 4 plus 1 equal to 0. Okay or not? So, s minus 2 whole square is equal to minus 1. So, I can say s is equal to plus 2 plus minus root over of minus 1. So, it is nothing but a 2 plus minus j. So, I can say this system has a 2 pole, P1 is equal to 2 plus j, P2 is equal to 2 minus j. Now, what is required? I have to represent the transfer function in a fractional sum. So, I can say that it is nothing but a k equal to 0 or k equal to 1 to n minus or n ck divided by ck into hk. I can say that. So, or I can say this hs is nothing but a h of as is equal to c1 by c1 into, I can say that c1 by s minus p1 into s minus p2 plus c2 by s minus p1 by s. So, it is nothing but a ck divided by s minus pk. Okay. So, C1 P1 divided by S minus P2. Now, how do I get the value of C1? I know that C1 by S1. So, I can say that H of S into S minus P1 at S equal to P1 give me the C1 value. So, what this is nothing but a H of S. So, it is nothing but a C1 is equal to H of S is nothing but a S plus S minus 2 into S minus P1 divided by S minus P1 into S minus P2 at S is equal to P1. So, I can say this cancel. So, it is nothing but a S is S minus 2, S is P1. So, it is nothing but a 2 plus j minus 2 divided by S minus 2, S is 2 plus j and minus 2 is there, S minus P2. So, S is nothing but a 2 plus j. What is P2? P2 is nothing but a minus 2 minus j. Minus 2 plus j. So, I can say that these 2 cancel, 2 cancel. So, it is nothing but a j by 2j. So, it is nothing but a half. So, I can say C1 is equal to half, C2 is also will half. So, I can say H of S is nothing but a half of H of S is nothing but a half of H of S. I can say that is nothing but a half of S minus P1 into S minus P2 plus half of S minus P1 into S minus P2. Now, I know what is the value of S, what is the value of Z. So, I put that S and Z, I get that value. So, that way you have to determine that Hz, because I have to find out the Hz. Okay. Next problem is, let us say this problem. This problem is related to the chapter number I think 2 or 1, not 2, or I can say the lecture number week number 1. So, this will be here, week number 1. So, what I said? I said that consider a signal processing simple signal processing system in figure. This one is the signal processing system. If the signal xat is applied at the input, determine the expression of the output yat. So, there is an analog to digital converter, digital to analog converter. So, what is that Fs in, let us say this is F1 and this is F2. So, what is value of F1 in here? 1 minus 5 millisecond, which is nothing but a, told me 1000 divided by 5 hertz. So, 200 hertz. So, sampling frequency of the signal is 200 hertz. So, what is the signal? This one is my signal. So, I can say XAT is nothing but a 15 cos 2 pi. What is the analog frequency? 60 hertz divided by 200 n plus 6 cos 2 pi. What is 500 means 250 divided by 200 n. So, that is nothing but x of n. So, I get the expression of x of n 15 cos So, I can say 3 pi by 5, okay or not? 3 pi by 5 n plus 6 cos so 5 pi by 2 n. Now, I know if the signal is separated by 2 pi, the signals are identical. So, I can say it is nothing but a 15 cos 3 pi by 5 n plus 6 cos 2 pi plus, told me, pi by 2 n. 2 pi plus pi by 2 n. So, I can say the signal is separated by 2 pi are identical. So, it is nothing but a 15 cos 3 pi by 5 n plus 6 cos pi by 2 n. Now, what is the discrete frequencies F1? Discrete frequency is nothing but a cos 2 pi into 3 by 10 into n plus 6 cos 2 pi into 1 by 4 n. So, I can say the discrete frequency F1 is equal to 3 by 10. F1 is nothing but a f by Fs. F is the analog frequency, and F2 is equal to 1 by 4, which is nothing but a f by Fs. Fs is the sampling frequency, f is the analog frequency. So, analog to digital to analog conversion, what is the sampling frequency? 2 millisecond. So, I can say f, this is Fs, this Fs or F2 I can say. F2 is equal to 1 by 2 millisecond. So, it is 1000 divided by 2 is nothing but a 500 hertz. So, I can say f is equal to, so this is F1, let us say this is F2. F1 is equal to 3 by 10 into Fs, 150 hertz, and F2 will be 1 by 4 into Fs. So, I know it is nothing but a 125 hertz. So, if you see that input analog frequency is my 60 hertz and 250 hertz. Here I get 150 hertz and 125 hertz analog signal. So, I can get that. Okay. So, what is the expression? I can write down the expression easily. Okay. Now, let us see the question number 4. What I said? The following figure represent an sampling rate conversion system. If the signal xn is applied in the input, determine the value of y2 and y4. So, what is x of n? X of n, what is the sampling representation? 2 is the 0th sample, then I know 2 is the 1 sample, minus 1 is the 3rd sample. So, that means 0, 1, so it is minus 3, that means 0, 1, then 1 0 will be there, then minus 1, okay, and then minus 5, then 4 and 5. So, this is 0, this is 1, this is 2, this is 3, this is 4, this is the 5th sample. Then, so there will be another 5th, sorry, this will be 6, let us 6, then 2, that is the 6th sample. Now, what I said, dissemination by 2. So, every alternative signal will be said. So, I can say y of m is nothing but a, so x of m is equal to v of m. So, y of m is nothing but a x of 2m. So, I can say that, so y of 0, so what I said, y of 2 is nothing but a equal to x of 4. So, what is x of 4? X of 4 is equal to 0. Y of 4 is equal to x of 8, which is equal to again 0. So, that way I can do it. Okay. Similarly, question number 5. This is an good question, and you can see that this required a lot of calculation. This required a lot of calculation. That is why I go to that page first, then I do it. So, second order LPC analysis was performed using a signal x of n is given 1, 2, 0, 3. That means x of 0 is equal to 1, x of 1 is equal to 2, x of 2 is equal to 0, and x of 3 is equal to 3. And partial reflection coefficient is k1 and k2, because order of the analysis is 2. So, what I have to find out? Determine the value of the forward prediction coefficient k1 and k2. So, how do I get that? So, as you know that so how do I get the minimum value of k1? Mean square error. So, I can say d dki of E mean square error is square m. So, I know that this is nothing but a d dki of E I minus 1 m minus k b I minus 1 m minus 1. So, this is I have to derivative it square. So, the square means it is nothing but a 2 into E I minus 1 m minus k b I minus 1 m minus 1 multiply by b I minus 1 n minus 1. So, I have to find out. So, mean square error equal to 0. So, this is equal to 0. So, I can say that ki, this multiply by this and this multiply by this. So, I can say ki is equal to E I minus 1 m b I minus 1 m minus 1 divided by b I minus 1 m minus 1 whole square. So, now m varies from, so there will be a sum, m varies from 0 to n minus 1. So, here also m varies from 0 to n minus 1. So, what is n? N is the length of the signal. So, what is the length of the signal? The signal length is 4. So, I can say that this is this is n equal to 4, 4 minus 1 means 3. So, I can say k1 is equal to summation of m equal to 0 to 3 E I minus 1 m multiply by b I minus 1 m minus 1 divided by m equal to 0 to 3 b I minus 1 m minus 1 whole square. Okay. So, I know that. So, now I put I equal to 1. So, I say k1 is equal to m equal to 0 to 3 E0 m multiply by B0 m minus 1, then divided by m equal to 0 to 3 B0 m minus 1 whole square. Now, as you know that E0 m is equal to B0 m is equal to xn. So, I can say that E0 0 is nothing but a x0 or equal to B0 0. So, if my x is 1, 2, 0, 3, so x is 1, 2, 0, 3. So I can say E0, 0 is nothing but a 1 multiply by E0, B0 minus 1. Minus 1 means 0 plus E1, 2 multiply by the m equal to 1. So B0, 0 which is nothing but a 1 plus, so 1 after 1. So I can say 0 multiply by 2 plus 3 multiply by 0 plus 0 multiply by 3. So I can say that it is nothing but a this term 0, this term 0, this term 0, this term 0, it is nothing but a 2. So this term is 2. Now what is this term? This term is nothing but a square. So whether 0 will be not there, so 0 square plus 1 square plus 2 square plus 0 square plus, so sorry, this will be m minus 1 plus p. So p is equal to 2. So that's why m minus 1 plus p. So 4 minus 1 plus 2. So this will be 3 plus 2, 5. So it is m varies from 0 to 5. Because second order analysis, so 0 to 5, n minus 1 plus p. Okay. So now I get this one will be plus 3 square. So I will get how much? 1 plus 4 plus 9. So it is nothing but a 14. So I can say the K1 is nothing but a 2 by 14. So it is nothing but a 1 by 7. Then I have to calculate K2. So when I say calculate K2, K2 is nothing but a, I have to set m equal to 0 to 5, E1m, B1m divided by 0 to 5, B1m, m minus 1 whole square. So I have to determine E1m. So what is E1m? So how do I get the E1m? I know EIM, so EIM is equal to EI minus 1 m minus Ki into BI minus 1 m minus 1. So I can say that E1m is equal to E0m minus K1 into B0 m minus 1. So from there I can calculate E1 0 is equal to E0 0 minus K1 into B0 minus 1. So from there I can calculate E1 0, I can calculate E1 1, I can calculate E1 2. Similarly, I can calculate B0 0, B1 1, B1 2. Then once I get that B1 and E1, I can calculate the value of K2. So that required a calculation. Then I say determine the expression of a Vm as a function of input xm in a multi-rate signal processing. So what is Vm? Vm is nothing but a x of m by 5. So what is required? So I have to 4 0 is inserted between 1 to 5th sample, 1 to second sample, where m is equal to 0, m is equal to plus minus 5, m is equal to plus minus 10, like that. Okay. Then so this is the signal, this kind of mathematics you can expected from that question paper. So I will say please carefully look into the assignment. Try to practice all the mathematics I have given in the assignment. That is very much important. If you practices all the mathematics, I am sure that you will be able to solve all the questions which is given in the question paper. Okay. So thank you very much for attending the entire course. So there is some review, the feedback that course is too much mathematics. Yes, signal processing is mathematics, but I try to make it, explain it as is your practical sense, and try to give you some assignment which can use your brain. You can see what is happening practically, because signal processing is really the application of, or you can say the physical phenomena is expressed in mathematical expression. So, that is why this is too much mathematics. Okay. So, thank you for your patience or attending the entire course, and I will hope that all of you will be perform better in the exam. And also, if you have any questions or any query regarding the any point, my email ID is available. You can send me an email or you can drop a message in your NPTEL forum, so that I will able to answer you. So, thank you very much for your kind patience. Okay, thank you.